Oh, I know.
Okay, good. So, Ankit, we have this thing called the AP test, and it is going to be happening next year. You have a calculator for certain sections of the test and certain sections not. I think the way it works is there's a multiple choice with calculator section and multiple choice without calculator section. Then there is a free response with calculator, 2 questions, and 4 free response without calculator. So this is a calculator question. And we need to practice this because calculator questions have their own style. They expect that you are very, very good with your calculator. And they want to make sure that you can do calculus not just with like fake, pretty silly little functions, but also with the like ugly, disgusting real-world functions that you would encounter, in the real world. There's such a place. So we have a problem right here, and it is a calculator problem. So please take out your calculator. For the love of God, put it in radians. And please take a minute and read this problem, and we're going to do it right now together. No. Please bring a calculator to school every day for the rest of the year, because we're doing lots of calculator things in this last year.
Do you have an Android? I do.
You're just going to share with Buddy Denton.
Wait, I was asking her.
Kindle.
Can you guys please focus and read the problem? Thank you. Oh, by the way, I should tell you which problem we're doing. We're doing the gravel processing problem. So yeah. So what's going on here? On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals, blah, blah, blah. Where t is measured in hours and the workday is from 0 to 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel, and during the operation, the plant processes gravel at a constant rate of 100 tons per hour. Would someone like to break this problem down to me like in real world terms? Just explain to me like what's going on. Use simple language. Eric, explain.
Basically, there's a gravel processing plant, and at a certain point, it's
What's happening at the gravel processing plant?
it's processing gravel and it's getting more gravel.
Yeah. So you're at this gravel processing plant, and there's gravel that's just like arriving at a continuous basis, So just imagine like a stream of like dump trucks that are coming and like dumping gravel to be processed. And then you're processing it. And how fast are you processing it?
Disgusting. Oh wait, no. 100 tons.
Yeah, so you're processing it at a constant rate because you just turn on the gravel machine and it just like starts humming away. But the rate at which it's arriving is like varying according to some like disgusting like cosine function. Someone kind of up on this? All right, cool. So now you have to ask all these questions. All right, first off, the very first thing to warn you about is when you have these calculator problems, please use your actual calculator. Do not try to do the problem by hand. Naaman, you're doing the common magnet student thing, which is like, I know how to differentiate this function, so I will. Don't do that. Every moment you spend doing algebra is like a waste of time. Do everything on your calculator. So step 1, let's just like put this function into our calculator. And maybe like as you're typing it, And I'm assuming that the majority of the class is on, what's it called, math print or whatever. So if you're one of those, if you're classic, then you need to like figure out how to do that. Where everything's like all fancy. And you might as well set your window to be from 0 to 8 because that's the length of the workday, so that's like a thing.
Do you want the U in
Oh
the
yeah,
side
yeah.
or
Yeah,
the
you have an advanced
U
job.
or
No, both.
Okay.
You have there and
Both?
like, yeah, figure out which lever. No, just like mostly on the
okay.
screen. If something on the screen's happening, you have to go back and forth. You can do it.
I know.
So good. And by the way, name it. What is this? What is this function? What does it represent again? The rate at which the gravel is arriving. It's not the amount of gravel, it's the rate at which the gravel is arriving. Okay, so let's do the first problem. Part A. Find G prime of 5 and interpret your answer in the context of the problem. Okay, so I fully expect that all of you can differentiate this function and use the chain rule correctly and blah, 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 and plug in 5, but the far more efficient way to do this, did I teach you guys Math 8? Well, if I didn't, I'm teaching it to you right now. So there's this thing called Math 8. Math 8 is numerical differentiation. It will essentially differentiate any function for you at a particular value. It's just going to find the derivative at a point. So we're differentiating with respect to x. And what is the function that we're differentiating? y1. Yes, so also experienced people, do not try to retype the function over and over again. Type it once correctly, and then do y1. You guys remember how to do this from last year? You go like vars, y vars, function, help each other.
It's around the
Y1.
thing. Clear. It's right there.
So we want to differentiate with respect to x the function which is in y1, and we want to do it at x equals 5. It's very pretty. Ta-da. Someone help her. Okay, good. So the answer is -24. Oh, another important thing to talk about. The AP exam assumes that when they give you a calculator that you're going to use the calculator to its maximum capacity, which means that they want all their answers rounded, their final answer rounded to 3 decimal places, truncating or rounding. Thus, there's only in this case, 2 acceptable ways that they will take this answer. As -24.587 or as -24.588. If you write -24.58, no points. You might as well have just written like, whatever, elephant sandwich, whatever you think, okay? No points. Okay, is everyone cool enough? 3 decimal places. Alright, now comes the hard part, and they want to see if you can like think and also write and use language. Explain, okay, what is the meaning of G prime of 5?
It's how quickly the rate at which the gravel is coming in is changing.
Yeah, it's kind of awkward to say a little bit, right? It's the rate of change of the rate at which the gravel is arriving, right? So G prime of 5 is -24.587. We can turn this into a sentence. We can say, the rate at which gravel arrives, at t equals 5 is it increasing or decreasing? Decreasing. And it's decreasing at a rate of -24.587, and what are the units?
Per hour. Or tons per hour.
Tons per hour per hour.
Tons per hour per hour, because G is tons per hour. So the rate at which the gravel is arriving is decreasing at a rate of tons per hour per hour. Is everyone cool with that?
Alright, tons per hour squared.
You can do that? Yeah, that's fine. Can you give me a new purple marker, please? One behind you. Okay, good. That was just really like a writing question. Is everyone okay with that? Just toss. Part B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this particular workday. Alright, how do we do this?
Change.
Yeah, we're just asking for, if we know the rate at which gravel arrives, and they want to know the total amount of gravel that arrives, then this is just a straight up application of the net change theorem, right? Okay, what's the answer? keep calling on you over and over again, so smart.
It's the integral at 5, or like between 0 and 5. Or for the whole day, so 0 and 8.
Yeah, it's going to be the integral from 0 to 8 of g. It's actually just like that simple, right? If g is everyone cool with this? If g is the rate at which gravel arrives, then the integral of the rate at which gravel arrives is the total amount of gravel that arrives. And we want to do it over the course of the entire day, so just math 9 and do the integral. Yes?
What happens if you give your calculator a completely BS function? Okay, never mind, I'm just going to test it. Go on.
Cool.
Wait, what? It gives errors.
It'll give you an error if you give your, probably it will give you an error if you give your function a, like a discontinuous function, for example. Yes, but, yeah, sure, play. So anyway, yeah, do it. Everyone knows how to do this? Yep. Did you get that? No. Okay, so the answer is 825.551. And what are the units? Yeah, tons of gravel. So that's how much gravel arrived. Okay, is everybody cool? Am I going too fast, too slow? All right, part C. Okay, do part C, go. Just think about it, figure it out yourself. Oh, okay. For the benefit of those who are on Classic, I'll show you how to do this. So hold on. Flip to Classic mode. So like the one I just did, for example, it's Math 9. And you just have to. So that's functional numerical integration. So you just have to memorize the syntax, which is the first one is the function. So bars, y bars, function, y1. And then you're integrating with respect to x. And then you're going from 0 to 8. I kind of prefer it actually. I don't know, it's fine. You like the other one better? Sorry. So you should just steal someone's T84. People leaving lying around like umbrellas. So and then the other one, you don't do the other one? We just figured out. Math 8. Math 8 is again, it's just like function differentiating with respect to x and Math 5. Cool. Okay, cool. Okay, I'm gonna go back to normal type though. All right, what'd you guys get? Explain. How'd you do it? What'd you do?
The rate at time equals 5. If you just plug in 5 to g.
Yeah, you just plug in 5 to g, right? Yeah, so you go bars, y1, and you just go like that, right?
We already did that.
So, no, we did g prime of 5. You have to keep things straight, right? G is itself the rate at which gravel arrives. We found the rate of change of the rate at which gravel arrives. If you want to know how fast the gravel is arriving, you just plug 5 into this function g. Follow? So yes. Caleb? Wait, we're not done yet, but that's like an important step.
Yeah.
So what's the significance of that number 98?
That's how much. That's like the amount of gravel arriving per hour at that time.
Right. Yeah. So at t equals 5, gravel arrives at g of 5, which is 98.141. What are the units?
Tons per hour.
Tons per hour. And keep talking, Caleb.
Well, the rate at which the gravel is being processed is 100 tons per hour, so
Yup.
the actual amount of gravel at the plant is like decreasing.
Yeah, but gravel is being processed at t equals, at 100 tons per hour. So if it's arriving at 98 tons per hour, but it's being processed at 100 tons per hour, that means that the amount of gravel is decreasing. Yeah? And that's what they asked, right? Yeah. So amount of unprocessed gravel is decreasing at t equals 5. Is everyone okay with this? Okay. Part D is like the real part, which is probably worth like half of the points of this problem, but it's very similar to something we did yesterday. So, all right, go. Think about it. We'll talk about it in a minute. This is a combination of sort of thinking skills, calculus skills, writing skills, and calculator skills.
Are there really only 2 problems?
That is it.
Are there really 2 problems for 30 minutes?
No, you get, these problems take 15 minutes each. So they'll give you half an hour to do 2 of these, and then they'll give you an hour to do 4 for that. Some of them you can do in like 5 minutes, you know what you're doing. Some of them you have to like read it like a lot of times to figure out what's going on.
Yeah, it's not that simple.
Just printed it to the Magnet office. Can you go? Not do it. All right, so what are we trying to do? What are we doing in part D? Find the maximum amount of unprocessed gravel at the plant during the hours of operation. So we want to maximize the amount of gravel. All right, well, just like we did back in way back in March, whatever, when we wanted to optimize something, it's useful, I think, to just like write a function which we are trying to maximize. You don't have to do this, but it makes it much easier. So can we create a new function? What do you want to call it?
Little g.
H. No, we already have a g.
Okay.
So let h of t be the amount of gravel at time t. Amount of unprocessed gravel at time t. Okay. So what is h of t?
500 plus like.
Oh, first, Caleb would like to remind us that we start the day with a pile of 500 tons of gravel. So that needs to be worked in there somewhere. Okay. And then what's happening throughout the day?
Like you're like adding gravel, and you're also processing gravel and getting rid of it.
Right. So throughout the day, there's gravel that's arriving. There's also gravel being processed. So how much gravel do I have at any given time?
So it's like plus the rate at that current time.
There's sort of 2 ways of thinking about it. One way is
You add g of t.
yeah.
Like you add g of t and subtract.
Yeah, but you're missing a key thing.
Then you times t.
Times t.
No.
Careful. Yeah.
You have to subtract 100 times t, because that's the amount.
But from what? We haven't done anything.
From this,
From everything.
the integral.
Integral
from 0 to t.
Yeah, okay, so that's one way of thinking about it. One way of thinking about it is I have this much gravel at the beginning of the day. Are you cool? Grab a seat, get some paper, and begin. Okay, they'll be all gone soon, yeah.
Just like the interval from 0 to t of g of t.
Yeah, so, right, so there's basically, yes, right? There's this much gravel at the beginning, and then we take the integral from 0 to, should we use a different, well, let's just do f, or let's just do, well, yeah, sure, we can just do that. Of g of x, right? Because remember, g is the rate at which gravel is arriving. So the integral from 0 to t of the rate at which gravel is arriving is the amount of gravel that has arrived. Follow? But then we also have to subtract out the gravel that's being processed, what's the formula for the amount of gravel that's been processed by time t?
100 times.
100 t. That's one way of thinking about it. Another way of thinking about it, which is totally equivalent, which some of you might be more comfortable with, depending, is actually just to say it's the integral from 0 to t of, like, just the rate at which the gravel is changing. And what is the rate of change of the gravel at any given moment?
G of x minus 100.
G of x minus 100, right? Because if g is the rate at which gravel is arriving and 100 is the rate at which gravel is being processed, then the difference of those two rates is like the net rate of change of the gravel at any given moment, and you integrate that. Of course, if you do this integral, we know that you can split this integral up and you get that, right? So both of these should make total sense to you. How are we feeling? Okay, good. Now that we have written an expression for h of t, all we need to do is maximize it. Okay, so how do we maximize a function?
Use the calculator.
Yeah, okay, but specifically, give me.
You put the function in the calculator and then you.
Wait, no. Can you use calculus words? How do we maximize a function?
Find where the
Take the derivative, find points where the derivative is 0.
And
changes from
from positive to negative.
the endpoints, right? It's a three-step process. Find endpoints and find the places where the derivative changes from positive to negative. Okay, let's do endpoints first. What is h of 0? How much gravel is there at time 0?
500.
500. Yeah, duh. How much gravel is there at the end of the day?
825.55. The number that we got earlier.
It's the number we got earlier, plus 500 minus 800, basically, right? Is everyone okay with that? Or the other way to do it is to go into y1 and make a new function y2, which is actually like y1 minus 100. This is how I'm going to do it, right? My y2 now represents, camera work, y2 now represents the net rate of change of the gravel at any given time. Follow? Okay, so now I'm actually going to do this. I'm going to just say that the total amount of gravel at the end of the day is 500 plus the integral from 0 to 8 of y2. You guys with me? Hopefully you are. What's y2? y2 is is just y1 minus 100. So did you guys get that? If you did it either way, you should have gotten that number, right? Okay, so that means the amount of gravel at the end of the day is going to be 525.551. Okay, what's left to find? The relative max, right? We need to find the relative max. So essentially what we need to do is we need to take the derivative of the h function. Well, when you take the derivative of the h function, what do you get?
G of x minus 100.
Yeah, you just get g of t minus 100, right? It's just the fundamental theorem of calculus. The 500 disappears, and when you differentiate the integral of a rate of change, you just get that rate of change. Is everyone cool with that? So the thing to do now is to figure out when g of t equals 100. But you have a calculator, so now what you're expected to do is go back into your calculator, just as I have done. You could put your cursor over the y1 equals so that you're no longer graphing y1, but we should be graphing y2. y2 is the difference in the rates of change of these things. And now I'm going to change my window, because I did this problem yesterday, from like negative 100 to 100, and I'm just going to graph this on the interval from 0 to 8. And I'm going to see that somewhere around like 4.9, it looks like, there's a change from positive to negative, indicating a relative max. And if you think about what's going on here, that means that if the net rate of change is positive, that means that I'm processing the gravel faster than it's arriving, I think, right? No, other way around. I'm processing it slower than it's arriving. But towards the end of the day, the net rate of change is negative, which means more gravel's arriving than I can process. I think I did that right, yeah? I think I said that right. So anyway, I need to find that point. How do I find that point? Again, using your calculator. So there's a 0 function. You go second calc 0, and it's going to ask you for a left bound. It's going to ask you for a right bound, and then it's going to ask you for a guess. The guess is like the seed to a Newton's method type algorithm, which is going to find the exact 0 up to the number of decimal places on your calculator. And it turns out that h prime changes sign, I'm going to run out of time again, from positive to negative at t equals 4.923. So H has a relative max at t equals 4.923. All right, and the last thing we have to do is see how much gravel there is at time 4.923. You guys with me? Okay, but I can't use an estimate. I have to use the exact number in my calculator. So there's a method for this. I know you learned it last year. But when you ask your calculator to find the zero function, it will dump that number into like x. So you quit out of the calculator, and if you type x on your home screen, there's your number, up to the number of decimal places stored in your calculator. And you take that number and you need to store it somewhere that's like less volatile, like A. Everyone knows how to do this with alpha? Nod vigorously if you understand what I'm talking about. If not, figure it out. Okay, good. Now that that number, where that relative max has been stored, the last thing I need to do is find out how much gravel there is at that time. How do I do that? Plug it in, right? I plug it into H. So now I want to do H of 4.923. But even though I'm writing 4.923 here, I'm always using the stored value. No intermediate rounding. And the cool way to do this is it's just 500 plus the integral, 10 more seconds, the integral from 0 to A of y2, which is the rate of change, the net rate of change with respect to x. And the answer is that there are 635.376. Final answer is tons of gravel. And so the absolute max is that relative max. Follow? Okay, good. Can you hit the stop button? Thank you.